From the Hubble Space Telescope to Saturn's moon Titan, you're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. Since 1990, the Hubble Space Telescope has been in space on a mission to observe our universe like never before. And it's captured iconic space images for the general public and delivered unique astronomical observations to the science community. But after 34 years, Hubble is starting to show its age. We'll speak with NPR science correspondent Nell Greenfield-Boyce about her reporting on Hubble and the public's admiration of the telescope. Then, a new mission to the moon, but it's not our moon, it's Saturn's. NASA's Dragonfly spacecraft is a drone and will explore the surface of the moon Titan. We'll speak with Elizabeth Zibby Turtle about the autonomous mission to Titan. That's ahead on Are We There Yet? The Hubble Space Telescope has been in low Earth orbit for over 30 years and is still operating. But the telescope has lost one of its gyroscopes, which is part of its navigation and pointing system. NASA says it has a plan to keep it in operation with just one of the spacecraft's 3 gyroscopes. Billionaire Jared Isaacman proposed a private mission through SpaceX to attempt to save Hubble, but NASA has waved off that offer. So what's going on with Hubble, and why doesn't NASA want help to save it? Well, here to answer those questions is Nell Greenfield-Boyce, NPR's science correspondent. Nell, welcome back to the show.
Thank you so much. I'm so glad to be here.
So you've been covering Hubble quite a bit these days. What is the latest with it? Is Hubble really in trouble up there in low Earth orbit?
So NASA says that Hubble is not on its last legs, that Hubble is still doing great science and will continue to do good science for like another decade. They did just make a change in how the telescope points. So basically, in the past, it's relied on 3 gyroscopes to help it point in the direction that astronomers want it to point. And one of the gyroscopes has been so sketchy and dodgy and giving back bad readings and forcing the telescope to go into safe mode and just being a real pain. And so NASA announced that they've just given up on it, basically. They're moving into a new mode of pointing the telescope that only requires 1 healthy gyro. So instead of trying to use 3, one of which was bad, they're now going to use 1 good one and keep the other good one in reserve for the future.
Can you describe the importance of these gyroscopes? What are they meant to do, and why are they so important to Hubble?
So they sort of show how Hubble is moving, and it's important because Hubble needs to be able to point at things with great precision. So, it's looking out at the universe, and astronomers want to put one thing in focus. And so the pointing is like, NASA has described it as being able to point a laser at a dime that's 200 miles away. There's like all kinds of different components in this pointing system. It's not just the gyroscopes. There's been problems with them in the past. I mean, they've been replaced and repaired in other missions. And so NASA has a lot of experience with just dealing with sketchy gyroscopes. And so this whole plan of going down to a 1 gyro operation has been in their back pocket for years and years, like decades possibly, because the telescope's been up there for over 30 years, right? It went up there in 1990. This is not something that was unexpected. I think everybody knew this day was coming. And as a result, there will be a slight lack of efficiency. So the telescope will be slightly less efficient in how it moves around and points at things. And there's some things that the telescope won't be able to do, like it won't be able to track moving objects that are within the orbit of Mars. But on the other hand, this telescope is so oversubscribed. Like every time they put out a call for proposals, astronomers put forward so many proposals to use Hubble that only like the top fraction gets selected. So I don't think they're going to have any trouble finding good science to do with this telescope. Let's put it that way.
I still can't get the image of sketchy gyroscopes out of my head. I love the way that you described them. You did mention that this has been launched in 1990, and you mentioned that NASA knew that this day would come. But, is this just a sign of old age, or are there other issues that could be at play on the Hubble Space Telescope here?
So actually, its instruments seem to be doing remarkably well. It's had a pretty good run of health since its last repair mission, which was 15 years ago, right? So It's been a while since anybody's laid a hand on this thing. And like everything, like the cameras and, the various scientific instruments, it seems pretty healthy. It's really remarkable. There's always talk about what's going to happen to Hubble. What's the future of Hubble? Because it's lasted for so long and it is so iconic. And it's just in the public's heart, they have a little soft spot for Hubble in the way that they don't for other space telescopes. Hubble is the one that gave us pictures that were like on the side of U-Haul vans and on like lunch boxes. And, I think everybody can relate to it because like it started out its life famously flawed. It had that bad mirror and it was kind of a joke. Then they basically did the equivalent of giving it glasses and suddenly it was like this triumph and everybody got emotionally invested in Hubble in a way that they're just not emotionally invested in other space hardware. So NASA, is very aware that anything they say about Hubble is going to like get everybody's attention.
It got the attention of one billionaire, Jared Isaacman, who the space community will know as bankrolling the Inspiration 4 mission and also the upcoming Polaris Dawn missions. And he put forth the idea of trying to fix Hubble through the private sector. What happened with that?
Yeah, so that was announced in September of 2022. NASA held a press conference and everybody was buzzing about it because it had all these NASA people together with a representative from SpaceX and then Jared Isaacman, and it had something to do with Hubble. And everyone was like, oh, what could this be? And they announced that they were going to study the possibility that one of the Polaris flights that Jared Isaacman had already contracted with SpaceX to do in one of their capsules could go to Hubble and reboost it to extend its life, and then maybe even do some kind of enhancement. They had this press conference to say they were going to do a feasibility study. And so that was in September of 2022. And then nobody heard anything for a long time. They said it was going to take 6 months. And then, so I was curious and I filed some Freedom of Information Act requests and basically learned that they had looked at it, but people at NASA had some concerns about what would be involved and what the risks would be.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with NPR science correspondent Nell Greenfield-Boyce about the Hubble Space Telescope, the legacy it has made, and how and if it could be saved. It was really great reporting. What did you find from that FOIA request? What were those concerns that NASA scientists were raising?
The concerns had to do partly with the uncertainty about the maturity of the hardware that would be required. So there's a couple things here. One is boosting Hubble. So Hubble is in orbit, but it's subject to atmospheric drag and it's slowly coming down towards Earth. And if nothing is done, it's going to burn up in the mid 2030s, NASA says. So, one thing would be to just boost it up. But then as long as you're there, maybe you'd want to do something to make its useful scientific life last longer by putting some sort of hardware on the outside. And so this feasibility study looked at that. It looked at the possibility of boosting it and then installing some hardware on the outside that would enhance its pointing system and make it more productive for longer. So some of the concerns seem to be with the maturity of the SpaceX spacesuit for doing extravehicular activities. So if you wanted to put hardware on the outside of Hubble, you would have to connect that hardware to its power and its data, and that would mean going outside. And so far, nobody's done a spacewalk from a SpaceX capsule yet. And so Jared Isaacman and his team plan on trying that very soon in their first Polaris flight, but they haven't done it yet. And so there's this concern about risk to the telescope. You could hurt Hubble, but I don't think they thought it was impossible to do or implausible. I think they looked really hard at this, because it was quite an offer to be offered, a mission to Hubble that would largely be paid for by someone else. Now, NASA was going to have to devote resources to build any hardware. And obviously the time of the people who know Hubble, it wasn't like NASA wasn't going to have to contribute anything, but it was quite something to think about. And I think they looked at it really hard.
And what did NASA say about this? I know there's been a press conference recently. Did they address any of this plan publicly?
When I initially reported, they didn't comment, but then they held this press briefing to talk about moving Hubble to a one gyroscope mode. And the head of astrophysics at NASA, Mark Clampin, was there. And so people took this opportunity to ask him about this whole proposed Hubble mission. And He basically said that they had studied the available commercial capabilities and decided not to pursue a reboost at this time. And he was asked more specifically about the Polaris mission because Jared Isaacman has made some comments on social media. He said the team that performed the technical analysis made a formal recommendation. And so Mark Clampin was asked about that. He said it wasn't a go, no go kind of thing. And that what they were talking about doing in terms of like adding hardware was all just very notional. Like they hadn't really gotten into the weeds, the specifics about how it would actually be done. So that's what they said. So it sounds like that for now is not going forward.
What does the future of Hubble look like? It will not be up there forever, right? As you mentioned, it is being subject to atmospheric drag unless it gets boosted up there. What is the plan, and is there an end date in sight?
The end date is like mid-2030s. It's a big space object, and it's got some big components like its giant mirror that would survive re-entry. And so that's going to come down. NASA has got to decide, is it going to just like be okay with the risk of that? Or is it going to try to control its descent somehow? And then once you start talking about adding some sort of propulsion system to control its descent, you're just like, well, why can't that propulsion system boost it up? But then if you start talking about boosting it up, you're just like, well, maybe it needs to be enhanced a little bit, because if it's going to live longer, you want it to do its thing.
But as you mentioned at the start of our conversation, like Hubble has delivered us those iconic images, right? And even if it's the mid-2030s, that's 40 years for a spacecraft is a long time to live in that harsh environment. Before I let you go now, what do you think Hubble's legacy will be when that eventually does come to an end?
I think that it certainly got the public interested in the power of space telescopes. So when you look at, the amount of public support that helped propel James Webb forward despite its delays and its being over budget. I think the fact that the astronauts were able to fix it in space and repeatedly fix it in space showed the potential for that kind of in-orbit repair. I think that in general, it was a big science astronomy project that was a resounding success. And it brought together the two parts of the NASA's portfolio, human spaceflight and the science part, that don't often come together in quite the same way. It's an interesting example of what can be done in space for science with the help of astronauts. From that perspective, I think it's gonna have a legacy for sure.
And it's made quite a few desktop wallpapers for me. So
yeah, it's interesting. It's interesting. I saw somebody talking about how you can tell the difference between James Webb and Hubble. Obviously, they look at different kinds of light, right? But they produce pretty pictures, and I don't think the public totally gets the difference. And you can tell like by how many points the stars have. If it's 4, it's Hubble, and if it's 6, it's James Webb. I think I have that right. But it's a mind-blowing telescope. Webb is, but Webb and Hubble in combination is even more mind-blowing because they each have different capabilities, and so when you add them together, you get these like super amazing abilities to like do all kinds of stuff. But NASA's got other space telescopes in the works, right? Like, and it takes a long time to build and launch new ones, and it takes serious money, and so you get this question like, at what point does putting more money into Hubble not make sense?
We've been speaking with Nell Greenfield-Boyce. She's a science correspondent at NPR. Nell, thank you so much for joining us.
Thank you.
Still to come, a mission to the surface of one of Saturn's moons. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. There's a lot of excitement about NASA's upcoming moon mission, and a new mission is joining the frenzy. But it isn't a mission to Earth's moons. It's a mission to one of Saturn's. NASA's Dragonfly mission is targeted to launch in 2028. The autonomous rotorcraft will fly to the surface of one of Saturn's moon, Titan. Here to talk more about this lunar mission is NASA's Elizabeth Zibby Turtle, the principal investigator of the Dragonfly mission. Zibby, welcome to the show.
Pleased to be here. Thanks for having me.
Thanks for coming to chat about this super exciting mission, Dragonfly. Before we get into the guts of this mission, let's talk about a pretty critical milestone the mission reached last month, right? NASA confirmed the mission. What does that mean?
Yes. Yeah, it's a major milestone, and the team has been working so hard over the last several years to get us to this point. So everyone's really thrilled to be at this point and be confirmed to move forward. Confirmation, NASA, sets a baseline plan for the mission. So we've coordinated with NASA, provided information to them, and they set a baseline plan for the mission over the next several years.
So while you've been working on this, that's a step in a direction to getting this thing off the ground, right?
So Dragonfly was selected in 2019, and we've been going through our preliminary design phases and had our preliminary design review just over a year ago. So that's a key milestone, in terms of the review of the technical plan, and confirmation is another milestone along the process. We have our critical design review about a year from now. That's review of the detailed design for the mission, and we are working toward a launch in 2028.
Very exciting stuff. Let's talk a bit about where it's going. Dragonfly is heading to Saturn's moon, Titan. Give us a lay of the land. What does it look like there? Why are you so excited to send a spacecraft to this moon?
Titan is a really, really cool place. I mean, it is literally a very cold place, but it is also just a fascinating world in the outer solar system. So as you say, it's a moon of Saturn. So this puts it pretty far out in the solar system. And the materials are different, but the geological and processes modifying the surface are very familiar. So the landscape at Titan is very familiar. The bedrock is water ice. The atmosphere is mostly nitrogen, like our atmosphere, but the next major constituent is methane. And the methane does a couple of really interesting things. So one is that it plays the role that water does here on Earth. So there's actually methane clouds at Titan. There's methane rain and lakes and rivers and seas, which is spectacular. Titan is the only moon in the solar system that has an atmosphere, and that atmosphere is actually denser than Earth's atmosphere. So that's one of the reasons it's really, really exciting to be, going to explore there, because it's this very kind of Earth-like world, even though it's in the outer solar system and very different materials. Another reason that we're really interested in exploring Titan is the kinds of chemistry that may be occurring or have occurred on the surface of Titan as a result of the abundance of carbon from the methane in the atmosphere, and the opportunities for those products to mix with liquid water at the surface in the past and in the present day in Titan's liquid water interior ocean. The kinds of chemistry that may be occurring on Titan or may have occurred in its past could be very like the chemistry that occurred here on Earth early in our history, billions of years ago. So this kind of prebiotic chemistry that it's very hard to study in the laboratory. We can do, short-term experiments, but Titan's had, thousands, hundreds of thousands, millions of years to do these experiments, and the results of those experiments are sitting on the surface. So that's what we want to go do, is pick up the results of those experiments, chemistry experiments, and see how far chemistry has progressed in the outer solar system on this cold world.
Zibby, never have I heard someone explain an environment of methane clouds and rain as spectacular, but you're a planetary scientist, so I can see why you would think that. That prebiotic evidence there, is that what you find on Titan? Will that help fill some gaps into our knowledge of how you and I came to be on this planet, right? Is that why scientists like yourself are so interested in getting that evidence?
Yeah, what we're looking for is chemical clues to the kinds of processes that support the development of life. And so we want to understand how far, first of all, what are the materials available on Titan's surface? Carbon-rich molecules are there? Do the types of materials vary with the geologic history? So in places where that carbon-rich material has had the opportunity to mix with liquid water at the surface of Titan, in the past? How far has chemistry progressed? Are there amino acids and proteins or things like that? And so this will tell us a number of things. First of all, how easy it is for these kinds of chemical processes that can produce biologically relevant compounds, how easy it is for those to occur, how far that has occurred on Titan. We want to understand a number of different aspects of the chemistry and also just habitability in general. And what we want to understand is what other kinds of environments could have supported the development of life.
I'm hearing words like carbon rich, methane, liquid water. As a layperson and not a scientist myself, I am thinking those are kind of the building blocks to life. Is there the potential that there is living life on the surface of Titan, or you may find evidence of previous life there?
So Titan is very cold. It's 94 Kelvin. That's minus 290 Fahrenheit. It's almost unimaginably cold for someone living on the surface of our nice warm oasis on Earth. The environment there is certainly not conducive to life as we know it. We have no evidence suggesting that chemistry on Titan has taken the leap to biology that chemistry here on Earth clearly did in the past in Earth's history. We do with Dragonfly have the capability to detect different chemical biosignatures if that did actually happen on Titan, but we don't, as I say, we don't really have reason to think that that has happened on Titan. And fundamentally, what we want to understand is those early chemical steps that are very difficult to study on Earth because on Earth, biology is kind of overprinted everything, right? There's biology pretty much everywhere we look on Earth. And it's hard to, go back and study those first chemical steps because they were so long ago and there's so much else has happened since then. So Titan, gives us the opportunity to study those early chemical steps. So fundamentally, we're a chemistry mission.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with NASA's Zibby Turtle, principal investigator on the Dragonfly mission heading to one of Saturn's moons, Titan. It doesn't seem likely, in the very slim chance there is, Dragonfly has the ability to search for these, but you're more interested in the chemistry and not the biology. So
Exactly.
I don't know why. I mean, it's cold, but hey, they've got spectacular methane clouds, right? So it's not that
Yeah.
bad. Zibby, let's talk a bit about the spacecraft itself, because Dragonfly is extremely unique in how it is going to get around on Titan. Can you describe it to our radio and podcast audience what this thing is going to look like?
So with Dragonfly, what we want to do is take advantage of the fact that we have this great atmosphere at Titan. So the atmospheric pressure is about 1.5 times that here on Earth. The atmospheric density is actually 4 times that here on Earth. And the gravity is 1/7 the gravity here on Earth. So physically, it's actually easier to fly on Titan, right? A person could put wings on and soar over the surface, which would be a really fun way to explore Titan. For now, we're sending a robotic emissary. Dragonfly is designed as an octocopter. For those who are familiar with drones, it's an X8 octocopter, which means we have 4 pairs of rotors on the lander. It is not a small vehicle the way we're used to, flying vehicles around, drones around here on Earth. This is about the size of the Perseverance or Curiosity rovers on Mars. It's the size of a small car, which gives you another kind of intuitive sense of how much physically easier it is to fly on Titan than Earth, because we can send this very large vehicle to be able to fly, and that carries all of our different instruments from place to place on Titan, and allows us to get kind of a bird's eye view, if you will, of to scout out future landing sites, to decide on where we want to go, to make measurements of the chemistry of Titan, to understand the geological processes that are mixing, modifying, transporting material on the surface, and to understand the atmosphere. We'll even have the ability to listen for Titan quakes, for earthquakes on Titan, which should be pretty cool.
Very neat. I'm imagining flying around Titan, but in a lot of layers, right? You have to
Yeah,
have a nice
yeah.
parka on
You'd
or
need
something.
you need a really good sweater. Definitely.
When I think of Dragonfly, I was thought it as something small, like the Ingenuity copter, but this is a rather large spacecraft. And as you mentioned at the start of our conversation, Saturn's quite far away. Are you going to be flying this thing in real time, or how is it going to navigate itself on the surface?
So this is a much larger vehicle than the Ingenuity helicopter. It was so exciting to see, to see flight on another planet. Ingenuity is spectacular. The rotors are about the same size, interestingly enough. The Dragonfly rotors are about a meter, so about a yard. This is a much larger vehicle than that. And even at Mars, which is much closer, of course, than Saturn, the distance was far enough that Ingenuity had to fly entirely autonomously. And so that is the same. That is the same for Dragonfly, except we have a longer time.
And I know that when you are planning these things out, you have a life cycle of the mission. A lot of times it goes beyond that. But can you give us a sense of just how far this thing is going to be traveling on the surface?
Each Titan day is about 2 weeks long. And the plan with Dragonfly is to fly every other Titan day. So we spend almost all the time on the surface making measurements, sending data back and forth to Earth, commands back up to Dragonfly. Each flight will actually be 20 to 30 minutes or so, and we'll cover several kilometers in that time frame. And then over the course of our 3-year mission, we'll be able to traverse several tens of kilometers, possibly, more than 100 kilometers across the surface of Titan, exploring different areas.
And Zibby, finally, I have to ask, because you teased this at the start, one of the instruments on Dragonfly will be able to listen for Mars quakes. As an audio guy, is that a microphone? Do you have a seismometer on there? How are you going to be listening to, and will we get to hear what Titan sounds like?
So the answer is yes to both, actually. So we do
Cool.
have a seismometer that will listen for Titan quakes, and it's really going to be very interesting if there are Titan quakes. What we want to measure is how seismically active, this world in the outer solar system is. Titan is a very different seismic environment, right? We have a thick water ice crust over a liquid water ocean. That's very different from the kind of seismic environment we have here on Earth or at Mars. It's going to be fascinating from that perspective, the kinds of signals we get if there are Titan quakes. We will also have a microphone, and so we'll be able to listen to Titan. We'll also really probably mostly hear Dragonfly, right? We'll hear the interior workings of the lander. We'll hear the rotors spin up, the drill for our compositional measurements. We actually have a drill that will break up the surface material and sample that to be able to measure the specific composition of the surface at Titan of the materials. And so we'll be able to hear that with the microphone as well.
Zibby, I cannot wait to hear and see what you find out once Dragonfly gets to Titan. Zibby Turtle is the principal investigator of the Dragonfly mission to Saturn's moon, Titan. Zibby, thanks so much for joining us.
Oh, my pleasure. Happy to share the excitement of exploring Titan with you.
That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Stay connected with the show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. Are we there yet? AWTY, get it? Also, if you got an idea for a future episode of the show, or you want to join us as a guest, reach out. We're at awty@cfpublic.org. We've got more space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Our intern is Sophie Diaz. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.